All right, we're now going to talk about finding distance using the distance formula. So let's go back and recap what we've covered earlier. So remember that if you're trying to find the distance between a vertical or a horizontal line, we're just going to count the spaces. And so remember, vertical is up and down, horizontal left or right. And we're just going to count. But if it's diagonal, if the line segment is diagonal, you can't just count it. So you can either use the Pythagorean theorem or we can use the distance formula, which we're going to talk about today. Okay, so we'll go through what that really means. So here, if we're going to find the distance using the distance formula, here is the formula. Okay, and the x sub 2 minus x sub 1, and you're going to square that, plus y sub 2 minus y sub 1, and you're going to square that, and then take the square root of the whole thing. And this formula is derived from the Pythagorean theorem, but in this form, it is not on your formula sheet. Okay, and these are just from your x and y coordinates from the points that are given. So in order to find the distance, now in this case, the distance formula will work even if it's a vertical or horizontal line as well. I just think that might be a little easier to just count. But here, the first thing we need to do is we need to identify the coordinates. So x of 1, y sub 1, x of 2, and y sub 2. And there gets a lot of confusion about, well, which one has to be the first set of ordered pairs and which one has to be the second set. It doesn't matter as long as you're consistent when you're putting in the formula. Because when I look at the 2 points on a graph, I don't know which one's the first one and which one's the second one. It doesn't matter. Either way you give them, they'll still work. And then once you identify your coordinates, you're going to plug them into the distance formula. So if we look at this example here, they didn't tell us the ordered pair, but we can go through and figure this out. So we know this ordered pair here is negative 4, negative 4. And then this ordered pair here is at 2, 5. Okay. And so like I said, it doesn't matter which one you consider the first ordered pair or the second one. We're just going to label it. So I'm going to label this x of 1, y sub 1. And I'm going to do this x sub 2, comma, y sub 2. Okay, and then those sub numbers, the little 1 and the little 2, are just so you can name them. So x of the first order pair, y of the first order pair, and so on. And now we're just going to plug those coordinates into the distance formula. So we have distance is equal to the square root, and I just kind of like to draw this all long so I can fit everything. And so in our case, what we have for x2 is 2 minus x of 1 is negative 4, so make sure you have minus negative 4. And then you have to square it. Don't forget that part. Plus, now we're going to do the y. So y sub 2 is 5 minus y sub 1, again, is negative 4. So don't miss your double sign. And then you're going to square it. All right, so now we're going to follow order of operations underneath. So remember, in order of operations, we're going to do parentheses first. So 2 minus a negative 4. Remember that joins and make a plus, so that's really 6 squared plus 5 minus negative 4. Remember, we're going to 5 plus 4, so that's 9 squared. So next, in order of operations, we're going to do exponents. So 6 squared, 36, plus 9 squared, 81. And now we're going to do our addition under here. So 36 plus 81, which is our 117. And then we're going to take the square root because that's what we have left. Don't forget that part. And then again, you can put that in Desmos. And let's round to the nearest 100. So that's distance of that line using the distance formula is 10.82 units. And again, that should be the same because it's the same example from the Pythagorean theorem video. So you should see that you get the same answer either way. Okay. All right, so let's just do some practice problems. You want to find the distance between 1, 6 and 0, 7. So remember our first thing, let's go ahead and label. So we got x1, comma, y1, and this can be x2, comma, y2. And then we're just going to plug that into the formula. So distance equals square root. I like to make that kind of long. So x2, x of 2, 0 minus 1 squared plus 7 minus 6 squared. And remember, we're just going to follow through with our order of operations. So I have negative 1 squared plus 1 squared. Now we're going to do exponents. So this is negative 1 squared, which is just a positive 1, and then 1 squared is also positive 1. Let's add them together. So d equals the square root of 2. Don't forget to take the square root at the end, and then you can use your calculator. Find the square root, and let's round that to the nearest 100. So that's the distance between these 2 points is 1.41 units, whichever that may be, using the distance formula. Okay. All right, so for example 2, we want to find the distance between negative 8, 5 and negative 3, negative 8. So go ahead, pause the video, label your x of 1, y sub 1, x of 2, y sub 2, and go ahead and find the distance formula. Go find the distance using the distance formula. So again here, I went ahead and labeled my points. And so we had all the values plugged into the distance formula, and we're going to follow the order of operations. So after following through with the order of operations, making sure to take the square root at the end, end up with 13.93 units. Okay, and that's it. Now you know all the ways to find the distance.